Alright, our next example, example number 40 here at the bottom of the page, we are using our solving of an equation or a formula for one variable to put an equation into slope-intercept form. So we are going to put 2x plus 5y equals 15 into slope-intercept form by solving it for y. And once we have it in slope-intercept form, we're going to see what the slope and what the y-intercept, the b, are. So the first thing that we want to do in order to solve this for y is to highlight that variable so we can see what we need to do. Now in order to solve that for y, we're going to get this 2x away from the 5y. It's added to it, so we're going to add its opposite to both sides. And then we have 5y is equal to negative 2x plus 15. One of the things that you do not want to do is you do not want to try to add 15 and negative 2 and get a 13x, because these are unlike terms and they don't combine. Now it's really important that we take this numeric coefficient here, multiply by its reciprocal, which looks like division because it is, but instead of having it all the way across, we do each and every term, which is what I was trying to set up for you guys when I was showing you in those last formulas. So now what we have is y is equal to negative 2/5 x, and then plus 15 divided by 5. We want to simplify that to be 3. And now we can read the slope and the y-intercept. Our numeric coefficient of x is our slope, so the numeric coefficient of x is negative 2/5. That's our slope. And then our y-intercept, and our y-intercept is our constant, and our constant is 3, so b is 3, which remember that's an ordered pair, 0, 3. And so those are all of our answers. Now we're going to go ahead and we're going to do the next one as well. You might want to pause at this point, and you might want to try this one on your very own without my input. Okay, hopefully you've paused it, and now you can see if you got the correct answer here. So the first thing that we're going to do is we're going to get the 5x away from the y term. So we're going to add its opposite, so a negative 5x added to both sides. So negative 5x added to both sides, and that's going to give us that we have negative 2y on the left is equal to negative 5x, and then plus 12. Make sure you didn't try to add that 12 and negative 5 getting a positive 7, because that's not what it was. And then the next thing that we do is need to remove the numeric coefficient, this negative 2. So we're going to multiply by the reciprocal in each and every term, right there, there, and there. And then finally, once we've done that, we're going to go ahead and we're going to rewrite it as y is equal to, a negative divided by a negative is a positive, so we want to simplify that to positive 5/2 x, and then positive divided by a negative, which is a negative 6. You do want to simplify the signs. I will mark points off on a test or a quiz if you do not simplify signs. My slope, which is the numeric coefficient of the x, is equal to 5/2. Remember, it doesn't have an x in it. And my y-intercept is the constant, which is a negative 6. And remember that I really do prefer to see those as ordered pairs, because we're going to have to label them if we graph it as a 0, negative 6. And there we go. That's our slope-intercept form. Now the next thing that we're going to talk about is the total value formulas. So I'm just going to briefly introduce this, and then I'm going to leave the problems to do in the next section. So total value problems are actually linear equations in two variables, except for the fact that our problems have no baseline. So we have a rate of change and we have an independent leading to a dependent variable. And that's what you want to remember for these problems. So I'll see you in the next video, and we'll talk about total value problems and solve a few of those.